All right. And since you're finishing this off today, I just want to give you some hints and we'll go over it on Wednesday instead of practicing any of the little area formulas and volume formulas. We'll just save that all for after break. It's not that long of a unit. I'll give you some hints on a few of these since these are just one more step than the ones we did for the most part. 12 here says prove that ABCD is a parallelogram but not a rectangle. Now, the first thing we notice, there's no axes, so you're going to have to add those in. So put them down somewhere. The numbers don't go very high, so we just got to be able to fit at most 6 in. So draw yourself some axes here. It says the use of the grid is optional. Can't help if you want to visualize it. It can't hurt, if you want to visualize it. Nor that first part, it definitely can help. Says prove it's a parallelogram. So that's going to be the same thing that we did yesterday. And then it says, but not a rectangle. So all you got to do, if something's a parallelogram, if you've already proved it's a parallelogram, the difference between that and a rectangle is a rectangle, all of the angles are 90 degrees. If you've already proved it's a parallelogram, we don't have to go through, though, and show that none of them are 90. If you can just show one angle is not 90 degrees, meaning the slopes are not negative reciprocals or not switched and flipped, then the rest of them can't be 90 degrees. (13), same idea. You got to put your grid down, your axes down if you want to use this. Jim believes that he has created a rhombus, so all 4 sides are the same, but not a square. A square is a rhombus, but all the angles are 90. So if you're trying to show that it's not a square, I mean, you could go through and show that none of these are right. But if you prove that one of them is not a right angle, then none of them can be. That's pretty much the same thing. On 15, and this is the last one I'll give you a hint on here, says prove it's a parallelogram. Okay, same as yesterday, but not a rhombus. A rhombus, all 4 sides are the same length. So we're going to have to use a slope formula and the distance formula here, but if you want to prove it's not a rhombus, all you got to do is find 2 sides that are not the same length. And just think about it. If you're looking at a rhombus, and I'll kind of exaggerate this one for you, don't choose the top and the bottom to prove it's not a rhombus. If you're looking at a parallelogram, those are going to be the same. It'll be like maybe that side and that side. I mean, you can see it. The 2 adjacent, the 2 consecutive, meaning right next to each other, touching each other, those may not be the same. So you'll have to use the distance formula for 2 consecutive sides or 2 adjacent sides, whatever you want to call it, and show that they are not the same distance using the distance formula. So that's the hint for those. And we'll go over those Wednesday for the first half, and then you're done.